quiz 5 in terms of like quiz 5 or the, isn't it in here? Oh, that thing. Yes, gotcha. All right. So last day we were looking at Roman numerals. And today we are going to focus on when do we use them. So this particular one, this is on page 26. It's called Roman numerals or not. And has anyone read any Asterix and Obelix books or Obelix? Yeah? Okay, so if you have, you'll be familiar with Asterix and Obelix and then the Romans. And so this is just a reminder of what your Roman numerals are, 1, 2, 3, 4, 5, and dogmatics makes 6. And if you haven't read them, they're really funny, and I would recommend them, but maybe you're a little old for them now. I don't know. At any rate, Roman numerals are only ever used for cations. I think we mentioned that last day. So we might have copper, which is the cation, and it uses a Roman numeral. That's good. However, oxide is the anion, and we do not want to use a Roman numeral for the anion. Remember that the Roman numeral is kind of like a middle name. So cation, yes, Roman numeral, anion, no Roman numeral. Now, the other thing you should know is that Roman numerals are only used for what we call multivalent cations. Now, the prefix multi, what does multi mean? More than one. And then at this point, you probably are not too familiar with valent, but it has to do with the valence electrons. And what it means is that you can lose different amounts of valence electrons. Okay, so basically we have more than one possible charge. So that would be like iron 3 or iron 2. Both of those are correct. Iron 3 is good. Iron Roman numeral 2 is good. But we don't want to use it for calcium, which is not in the red zone. We can change that to gray zone if you like. Okay, so all your multivalents that need Roman numerals are in the gray zone. So if it's in the gray zone, yes, Roman numeral. If it's not in the gray zone, no Roman numeral. And the reason for that is that calcium is always 2+. You're not wondering, what charge is calcium? You're like, it's in group 2. It is 2 plus. So I don't need to write a Roman numeral, and so I shouldn't write a Roman numeral, right? It's like if there's 2 different people in the class with the same name, right? And I'm handing back papers, right? I might say Andrea M, and I might say Andrea S, right? Because I have different Andreas in the class. But what if I only had one Andrea? Would I wander around calling her Andrea M? No, because I don't need to, because there's only one of them. So that's why we use the Roman numerals when we have more than one possible charge, and we don't use them when we don't. All done? Thank you. Okay. So you're going to look at your periodic table. You're going to look for the gray zone. Sodium, for example, if we look at our periodic table, is sodium in the gray zone? No. So do we use a Roman numeral? No. Not in the gray zone. Do not use a Roman numeral. Okay? It's not in the gray zone. Therefore, there's going to be no Roman numeral. Okay? Now, iron, on the other hand, if we look up iron and we go back to our periodic table, here is iron, and it is indeed in the gray zone. All right, and so we say iron, yes, red zone, or gray zone. Yes, Roman numeral. And I'm just going to write Roman because I ran out of room, but you guys can probably figure that out. So what you're going to do then is for sodium, you just write sodium, and there is nothing here, okay? Nothing. But for iron, because it is in the gray zone, we have to say it is iron 2. And remember that that Roman numeral is the charge of an iron ion. Now, would anyone like a review of how to find the Roman numeral from the name? Yes, please? Okay. So once you do this, you're going to be like, okay, I'm good at determining which ones need it. So what you're going to do in this one, and I'll just do a few of them as examples. So I'm going to start with LIF. This is on page 27. LI, does LI need a Roman numeral? No, it does not. So if I go back here, I'm going to name this lithium, and I don't need a Roman numeral, so it's just lithium fluoride. Do I need any prefixes here? No prefixes, because these are all ionic compounds. They all start with a metal. Okay? So that some of them won't have Roman numerals, but some of them will. So let's take a look at Cu2O, number 6, Cu2O. So I'm going to do it over here. We have Cu2 and O. Step number 1, you're going to write out all the ions. And guess what? On this page, there's not really enough room to do that. So what should you be getting yourself? Get scrap paper, okay? Seriously, I've put stars here, use extra paper, okay? Because otherwise you won't have room to write out all the ions and you will most likely make mistakes unless you're really good at doing math in your head, in which case go for it. Do it. Okay. So we have 2 Cus. And how many O's do we have? Just the one, because there's no subscript. Secondly, we look up the charge of the anion, the negative ion. And we can find that that is 2 minus. We're going to find the total negative charge. And in this case, that's pretty easy because there's only one thing, so the total's got to be just 2 minus. What does the positive charge have to be, the total positive? Same thing, okay? They have to be equal and opposite. Total positive has to equal the total negative. And then we split up the positive charge onto the cations. So if I have 2 plus in total, what is the charge of each copper ion? 1. So I have 1 plus and 1 plus. You don't have to write the 1. In fact, it's usually we don't, but just, you know, because we're worried about numbers here, I'm going to write it. And once we have that, this right here, the charge of a single copper is our Roman numeral. So the charge of on a single cation is the Roman numeral. Okay, so this would then be named Cu as copper. And then we would have a Roman numeral 1. And then O is oxygen, which becomes oxide. Would we like a more complicated example? As big and bad as it gets? Shall we do as big and bad as it gets? Okay, we're going to do a horrible big bad one here together. And you can be guaranteed it will never get worse than this. Okay? Mn3 N7. Ooh. Okay. So bear with me here. You're going to have to write down 3 MNs. Mn. Ooh. Then you're going to have to write down, oh my gosh, 7 Ns. trust me, on a quiz, I haven't given you any with 7 in it, okay? 1, 2, 3, 4, 5, 6, 7 ends. Holy moly. Now, each of these ends has a charge of 3 minus. 1, 2, 3, 4, 5, 6, 7. What is 7 times 3 minus? Negative 21. Which means our total positive charge has to be how much? Positive 21. The MNs each have to be 7 plus. 7 plus, 7 plus. So this would be manganese. What's the Roman numeral for 7? VII. Manganese 7, and then is it nitrogide? Nitride. Okay, so that's worse than anything you're ever going to see. Okay, I'm not giving you any with 7 pluses because that's just like way too much work. Okay, there might be like 1 5 on there somewhere, just, you know, but certainly not a 7. And I think I will leave it there for now. You guys can practice and work on quiz number 4 if you haven't already done that. And where's my marks book? What have I done? Thank you. You can you know what? You can start reading through the stuff on quiz